FGM-3 update 4. I've now got the FGM Mate connected to 200 feet of Cat5 Ethernet cable. I've secured it in a roughly east-west orientation. We just used some double-sided adhesive tape so that the sensor does not move. And this is back in a room that is never used in my home, so there are some ferrous objects in here, but the key thing is they're not moving. There's really no power adapters or any electronics in this room, so this is probably the quietest, electromagnetically quiet spot in my home, and the sensor will not be disturbed. So that is running out into my living room. There's the bundle of 200 feet. The rest of it's just coiled up, tied up. And we'll go into the living room, and where the prototype is connected to this Cat5 over 200 feet to the breadboard. And we'll see if we're getting adequate supply, a return logic signal, and a good frequency. Okay, so the other end of the 200 feet is connected here to this modular jack I've just got wired up. It is receiving its power, and the 5-volt logic connectivity LED is lit. I'll check for a 5-volt regulation in a moment. It is plotting and sending back a frequency. One thing I do notice though, I don't know if this is the scope. The period doesn't seem to be changing, but if you look very carefully, it's like the triggering is every second is offsetting left and right. So I'll have to look at the data to see if this is a big change in period. To see that big of a change, if it is a change in frequency, then it's probably about 500 hertz to 1000 hertz. But then again, you know, this is the worst case scenario. So this is 200 foot of cable, and there could be some noise or capacitive issues with the cable being bound up and coiled like that. If you were using this length of cable, you would have it stretched out and not coiled up and buried in the ground, probably in conduit. But I know the sensor is it's in the back room back there. The door's closed. I know there's no source of interference back there. So the next step will be to see what's going on the oscilloscope. Is this just a triggering issue, or is the period changing? And check my regulation. If this test fails, then my next cable length signal degradation test will be with 100 feet. So I guess the next video will be my final results of using 200 foot of cable. But at least it is getting its supply, sending back an OK connectivity status, and not sure what the jumpiness is about yet, but it is sending back its signal. And it is a nice perfect square wave, but like I said, I haven't seen this shifting in the period, so need to narrow down, is that the scope or is that a change in frequency? And I'm not sure why that would happen every second. So that means I got some troubleshooting to do. Until then. Okay, so I think I narrowed down the problem, and I don't think it's cable length. My current meter had died while it was still allowing power to pass through it because it's turned on. I think that was causing either a voltage drop or some noise, coupled with the fact that a breadboard can become highly capacitive between tie points, and you know, while they're great for prototyping, they are prone to bad connections. So I was seeing a 5-volt rail that was not always regulated the way it should be. I also added the Bluetooth radio to test it, and I'm running that off the 3.3 volt rail to keep it separate. I had it on the 5-volt rail, and it was introducing some noise onto the 5-volt rail. But connecting it to 3.3 volt, which this particular Bluetooth radio will operate on either, seemed to remedy it, and now I've got a steady oscilloscope frequency output using 200 foot of cable. One thing to note about these are pretty popular for serial communication in Arduinos. This is a HC06 slave Bluetooth radio. You can get these for about between $6 and $8 on eBay, and they usually only come with 4 pins: your power, ground, and then your RX and TX. There are 2 unpopulated pin headers for key and state, and a lot of people don't use these. The state just connects an external LED to the flashing red LED, which is supposed to indicate that it's in discovery mode. It's waiting to be connected to. When a connection's made, it'll turn solid. That's not entirely true, though. With these radios, I have noticed a timeout after about not really sure, because the data sheets are all in Chinese and hard to find. I think there is a data sheet that was translated, but it doesn't make mention of the discovery timeout, but it's somewhere between I'd say 2 and 3 minutes. Even though it's blinking, it will time out after a few minutes. But a way around that is the key pin header. If you'll just populate that, and then what you can do is connect the key connection, which is active low, to either the Arduino's reset, or you can connect it to a digital pin and hold it low for at least 100 milliseconds. What that's supposed to do is, on the HC05 master Bluetooth devices, that will enter an AT command mode. Pulling that pin low will allow you to program this with AT commands, but it also has the effect of resetting the entire board so that it is again discoverable. So one change to the design will be to move the power supply for the Bluetooth radio to the 3.3 volt rail, and what I'll do is add a it's a 4-pin header right now. I'll add another pin and connect that to the key, and then connect the key to the reset button on the Arduino. So if it times out, then all you got to do is hit reset instead of power cycling the unit. That'll prevent you from having to disconnect and reconnect the power. You could, in other applications, you could just if you have a spare digital output, tie the key to a digital output, and to reset the radio, take that pin low for at least 100 milliseconds and then back high again, which will reset the radio. I'm going to just manually reset it right now. Let's see if I get the right wire. So power cycle the radio, and I've got a Bluetooth adapter, just a generic Bluetooth USB radio. So I should have about roughly 3 minutes before this times out. And the software and firmware should already support Bluetooth, but this is my first test, so it may work, it may not. So let's run it. The configuration file is already set to Bluetooth mode. The Bluetooth radio operates at 9600 baud, while USB runs at 115,200. The pairing code and the name of the radio is okay. It did find the serial port service, but let's see if it actually connects. If it doesn't, then it's a matter of finding what the problem is in my code, because this does work on the magneto-resistive 3-axis digital models that I have. So it just may be some timing issues. There's some latency between when you send a request for data and then when that data actually is available to be sent. In my particular code, it's about 200 milliseconds. And through AT commands, you can change the name of the radio and the baud rate and the pairing code. Right now the pairing code is just 1234, but I'll probably change the name of the radio to like FGM or something like that. Okay, so it did find the radio and it did connect, but I'm not getting a serial stream. It is actually, it gets it every 10 seconds, and my timer stopped right at 10 seconds. So that means I've got a small glitch in my processing code, which I will narrow down later. But it does look like the Bluetooth is connecting, and it's not getting it off of the 5 volt rail and onto the 3.3 volt rail. Eliminated any noise that I was seeing. So far so good. It does look like the 200-foot length of cable works. I think the problem was a combination of a voltage drop through a dead multimeter coupled with some signal degradation due to the fact that there are capacitive and connectivity problems that can arise from using a breadboard. However, I think once this design is on a circuit board, which is much more cleaner and integrated, all of those problems will cease to exist. So for now, unless other problems arise, I will consider 200 foot of Ethernet Cat5 to work, but that'll probably be the maximum tolerance on this design. For most applications, I'm going to suggest using the shortest length of Cat5 possible, probably 50 feet, 25 feet, 100 foot, with 200 being the absolute limit.